All right, the goal of the next two lectures is how to solve an ODE on a computer, because that is usually the way that you'll solve ODEs after this course is done. Now, the simplest way of doing so is by using Euler's method, which I want to motivate now. So in particular, what you have, y solves a differential equation, y prime equals y squared plus 3t with initial condition 2. So y of 0 is 2. And you want to figure out an approximate value of the value of y at 2. So without solving it explicitly. And here's the main idea. The main idea is just to use the definition of a derivative. So recall that y prime is really the limit of a difference quotient. So limit h goes to 0 of y of t plus h minus y of t over h. In particular, this implies for small t, the derivative is roughly that difference quotient. So hence, for small t, or small h, we have that y prime of t is roughly y of t plus h minus y of t over h. And you can use this to solve for y of t plus h, roughly. So y of t plus h is roughly y of t plus h y prime of t. Now, this is an equation you may have seen in calculus, but now we can sort of interpret this in terms of what we want, because y of t is like the present, the info that we know, like maybe the initial condition, and y of t plus h is a future. And this equation tells us, well, the future is roughly the present plus hy prime of t. But remember, y prime of t is given by the ODE. We can actually calculate this because y prime is y squared plus 3t. And in fact, let's do this. So in this case, with t equals 0, that's where we're at, the present, and h is 2, goes from 0 to 2, it's 2 units, we get that, well, y of 2, again, the stuff we want to find, that is y of 0 plus 2. And using the equation above, this is roughly y of 0 plus hy prime of t, so 2y prime of 0. But once again, I want to remind you, y prime of 0, we can calculate this using the ODE, because y prime is just y squared plus 3t. So by the ODE, this becomes 2 plus 2 times y of 0 squared plus 3t, so 3 times 0, and we get a concrete value. So this becomes, I know, lots of 2's, 2 plus 2 times basically 2 squared, and you get 10. So what is this showing us in terms of a picture? So what we have, so this is maybe our solution, y of t. And we have y of 0 is 2. And essentially what we did, we used the derivative or the tangent line to figure out the value of y at 2, roughly. So this is 2, and we found y of 2 is roughly 10. So that's really what we did. It's sometimes called a linear approximation or a tangent line approximation. Now, of course, as you can see, the actual value of y at 2 and the approximation that we got are still very far apart. And the idea behind Euler's method is, instead of doing one step from 0 to 2, let's actually do 2 steps, from 0 to 1 and then 1 to 2, and doing the same thing. So idea, so instead of doing one step from 0 to 2, do 2 smaller steps. Steps. Basically from 0 to 1 and from 1 to 2. And I want to show you already on this picture how much better we get. Because once again, we have our solution, y of t. This is 0, this is 2. And the idea is, once again, what we can do 2 steps from 0 to 1 and 1 to 2. From 0 to 1, we use, again, the tangent line to get y of 1. And from 1 to 2, we use the other tangent line to get a better approximation, y of 2. And really compare how much better we get. Here, y of 2 was far apart, but now y of 2 will be closer. So in fact, let's do this, and then we can just generalize. So next example. Now find an approximate value of y of 2. Again, same ODE, but this time 2 steps. 1 2 step. 1 2 step. I wish you, everybody get on the floor. Okay. So once again, we had y of 0, which was 2. But now what we want to find, based on this picture, we first want to find y of 1. So y of 1 is again the future compared to 0. And remember, future is present plus the ODE, 1 y prime of 0. So here h is 1 in this case. So this becomes, again, by the ODE, this is 2 plus 1 times y of 0 squared plus 3 times 0. Here we just use the ODE. And this becomes 2 plus, I believe, just 2 squared. And that becomes 6. So this is our approximate value of y of 1. And the idea is we want to use this approximate value, 6, to evaluate y of 2. So use that value of y1 to calculate y of 2. So in fact, now let's do y of 2. So again, future is present plus ODE. So y of 1 plus 1, which is roughly y of 1 plus 1, y prime of 1. Again, in this case, x is 1 and h is 1. And then once again, by the ODE, this becomes 6 plus 1 times y of 1 squared plus 3 times 1. Well, you see, before we didn't know what y of 1 was, but now we have our approximate value. and we can just plug it in. So I think you get 6 plus 6 squared plus 3. So I think 36 plus 3, 39 plus 6, 45. So kind of completing our picture here, we had y of 1 was 6, again roughly, and then y of 2 was roughly 45. And what's the idea behind Euler's method? Just use smaller and smaller steps to get a better and better approximation. So kind of the essence of Euler. Sounds like a nice perfume. So take lots and lots of tiny steps. To get a better and better approximation. Just like in the picture below that I'll draw now. So once again, we have our y of t, a true solution, and then we just take tiny, tiny tangent lines like that. We start with y of 0, we go to y1, and then y2, y3. So not like y of 3, but this will be our approximations, etc., etc. And you can see, well, hopefully we get a very close approximation. And so in the next example, I will show you precisely how to do that in the next video.